akaja na principle yake. So now let us see the statement of the principle. Anasema kwamba this Hensberg uncertainty principle state that it is impossible to determine simultaneous, kwamba vitu ambavyo ni sambamba simultaneous, kwa sababu kumbuka de Broglie alisema kwamba both particle and wave nature, both particle and wave nature. Sasa kama ni vitu simultaneous, akasema kwamba it is difficult, it is impossible to determine the simultaneous, both the exact position and the momentum of that subatomic particle. Kwamba at the same time hatuwezi kudetermine the exact position and momentum of this subatomic particle. Kwa hiyo kuanzia leo utakutana na hili swali au utaulizwa swali, state the Hensberg uncertainty principle. This is the overall statement. Kwamba it is impossible to determine simultaneous both the exact position and the momentum of the subatomic particle. Only that. Kwa hiyo ukishaulizwa hili swali, this is the statement, or this is how to reply. This is the answer of the question. Kwamba ukiambiwa state the Hensberg uncertainty principle, kwamba it is impossible to measure or to determine simultaneous both the exact position and momentum. Maana yeye alivyoona ugumu pale, ndipo akaja kuchukua vice versa ya ile pale kwamba haiwezekani kufanya hichi kitu. Therefore so as you can able to determine the simultaneous both the exact position at the same time momentum, it is difficult. So now if the momentum is measured very accurately, the measurement of position of the particle become less precise. Sasa hapa ni jinsi gani alianza kutetea hoja yake. So the more clarification of this principle, anasema kwamba if the momentum is measured very accurately, kwa maana kwamba very very correct, accurately maana kwa usahihi, therefore anasema kwamba the measurement of position of the particle become less precise. Asa ile precise of the momentum, of the position of the particle inakuwa ni less, kwa sababu we have the momentum which is measured very very accurately. Sasa anasema similarly if the position of the particle become less precise, maana yake kwamba itakuwa ni vice versa. Maana yake kwamba itakuwa ni vice versa. So we have to note, kwa sababu yeye kule amesema it is impossible to measure or to determine simultaneous both exactly position and momentum of that subatomic atom or subatomic particle. So now anasema kwamba if momentum is measured very accurately, the precise of the position will be less. Similarly, if the position of the particle become less precise, maana yake kwamba momentum itakuwa ni vice versa. So similarly, if the position of the particle is measured accurately, the measurement of momentum become less accurate. Kwa hiyo ni vitu ambavyo vinaenda vice versa. That's why kwenye principle yake alisema kwamba it is impossible to measure simultaneous both the exact position and momentum of the subatomic particle. Kama ni impossible to measure exactly simultaneous both position and momentum of this subatomic particle, now anakuja kusema kwamba kama kimoja kitakuwa measured accurately, maana yake kwamba kingine ile precise yake itakuwa ni less. Sasa kama momentum itakuwa imekuwa measured accurately, maana yake kwamba the position will be less precise. Sasa tunapokuja kwenye position, kama yenyewe imekuwa considered very accurately, therefore the momentum will be less accurate. This is due to the wavelength of the energy applied to locate an electron in an atom being higher than the energy of the viewed electron. Kwa maana kwamba utofauti utakuwepo kwenye nini? Kwenye wavelength. Sasa kama kimoja kitakuwa measured accurate, maana kingine kitakuwa na less precise. Sasa kama momentum imekuwa ni less precise, maana yake kwamba tunapokuja kwenye position, therefore make sure itakuwa imekuwa considered very accurate, au itakuwa measured very accurately. Similarly, tunapokuja kwenye momentum kama imekuwa measured accurately, maana yake kwamba position itakuwa less precise. That's why anakuja kusema this is because the wavelength inakuwa inatofautiana depending on the energy applied there. Sasa anasema kwamba this is due to the wavelength of the energy applied to locate an electron in an atom being higher than the energy of the viewed electron. Sasa kwenye energy ambayo uliview zile electron na energy ambayo ilitumika kufanya location, just to allocate, is quite different. Therefore even the wavelength anasema kwamba will be also different due to the wavelength of the energy applied to locate but also to view that electron. So for example, the uncertainty associated with the measurement of the position, kwamba uncertainty principle, it is associated with the measurement of the position, and by measurement of the position we assume is like change in x, and the momentum ambayo ni change in p. Tunajua kwamba momentum inakuwa represented by with this letter ambayo ni p, na inakuwa sio p ile ambayo ipo upright, no, sometimes inakuwa kama italic fulani, inakuwa kama symbol fulani. So we can say that the mass change in velocity are related by Heisenberg equation as shown in the equation below. Sasa kulingana na hii relationship ya huyu Heisenberg uncertainty principle, yeye alikuja sasa na idea, kwa sababu relationship yake aliangalia kuhusiana na measurement of the position, momentum and so forth. Kwa hiyo akaja na equation ambayo ina describe idea yake. The equation is like this, kwamba change in position ambayo ni change in x times change in momentum is greater or equal to h over 4 pi. H tunaongelea Planck's, 4 pi we are talking about the radii. This one is the radius. Hii ni pi. I hope everybody know pi. Kwa sababu hii ni mathematical abbreviation. 4 pi. Kwa hiyo hii ni formula. We can say that the change in position ambayo ni change in x, mass change in v ambayo hii ni velocity. Ina maana hapa tunaongelea hii nini? Change in momentum. Sasa sana kuandika hichi kitu, mass change in velocity. Ina maana hii sasa na nini? Sasa na momentum is greater or equal to h over 4 pi, whereby m is the mass of the moving particle, kwamba m inawakilisha the mass of the moving particle, and this change in x is the uncertainty in position. Maana kwamba we are talking about the position of object or the particle. Lakini change in v is the uncertainty in velocity. Change in p is the uncertainty in momentum, and h is the Planck's constant. So you have to note this thing. Tunapomwongelea Heisenberg uncertainty principle, maana kwamba if we have this velocity, haitakuwa tena just only velocity. Tunasema kwamba ni velocity, the uncertainty in velocity. Ina maana kinaongezeka kitu. Uncertainty in momentum. Then you can see here uncertainty in position. Kwa hiyo tunaongezea ile uncertainty in position, uncertainty in momentum, uncertainty in velocity, whatever. Kama tulivyoona kwenye de Broglie kule, tuliona kwamba instead of saying just wavelength tunabadilisha, inakuwa ni de Broglie wavelength. Sasa pia hapa kwenye uncertainty kila kitu kinabadilika pia. Uncertainty in position, uncertainty in momentum, and so forth. So the product of the uncertainty in position and momentum is negligible in the case of the large object. Sasa tunapokuja kuconsider zile large object, hii uncertainty of the position and momentum obvious is negligible. When we say negligible, maana yake kwamba ni kitu ambacho ni very very small, ambacho kinaweza kuwa assumed is equal to zero au kikapotezewa kabisa. That is all about the negligible. So this agrees with the de Broglie equation, in which the wavelength of the large object is too small to be measured, hence insignificant. Asa hii nayo inakuja kurelate na idea ya yule de Broglie ambaye pia na yeye kuhusiana na ile large object alikuja ilikuja kuonekana is not significant. So unaona at the end the concept of this Hensberg na yenyewe pia at the end tunaona kwamba the issue of the large particle kwamba large object is too small to be measured, hence insignificant or is not significant. So that is all about this concept of uncertainty, Hensberg uncertainty principle. So my student, after there I would like to say this marks the end of our discussion. Thank you so much for watching our Media Educator TZ. Bye bye. I wish you a good time.